Okay, everyone. Good morning, everyone, and welcome to our webinar, Machine Learning for Advancing Human Aging Research. I'm Nitichen Kittiratchakool, and I have the honor of being your moderator for today's sessions. I'm a researcher at HITAP. It's a pleasure to welcome you all to this insightful discussions on the intersections of machine learning and human aging research. Okay. Slide is not work. Please next. Okay. Yeah. Next, please. And then next. Okay. Yeah. Firstly, I would like to extend our sincere gratitude to the World Health Organizations for their invaluable support, particularly through WHO Country Cooperation Strategy or CCS program, the convergence of digital health platforms and health information systems implementation in Thailand, or convert digital health. As we embark on the journey, it's important to recognize the power of machine learning, a subset of artificial intelligence, which has emerged as powerful tool in various scientific fields, and its potential in aging research is particularly exciting. Today, we'll delve into how machine learning is revolutionizing the way we study aging, opening doors to novel discovery and potential interventions. To give you a sense of how we will proceed, please go to next slide. And then next again. Okay. Here's today's agenda. We'll begin with a presentation on the applications of machine learning in aging research for about 30 minutes, followed by insightful discussions from 3 experts, about 5 to 10 minutes each, and 2 of them are joining online. We will then open the floor for Q&A sessions before concluding with some final remarks. Throughout this session, we do love to hear from you guys. So please feel free to send your questions to the Q&A box and we'll get to them at the end. And however, it's in the morning, so I think we should activate our brains a bit. Let's get some menting. You can scan QR code or type or enter the code that show on the screen.
Thank you, Ms. Nitichen. Good morning, everyone. I'm so glad to see you all today. We got an exciting activity lined up, and I would love for everyone to get involved. It's super simple. So we got just 3 quick questions for you to share your thought on. To get started, please go ahead and scan this QR code, or you can go straight to the menti.com and use the code on the screen. The code is 75430099. Okay, all right. Let's see.
15
we got
people now.
15 people with us now. Is that which? If you join, please press the like button to know how many people join now. Okay, I think we got 20 people with us now, and let's start it. Okay. Okay, go to the first question. How are you guys feeling today? Okay. Take a moment and think. Please share your response. Yeah. Okay. Excited? Good. Okay. I'm sure many of you are feeling excited. Awesome. Friday, yeah, it's Friday. Try someone. Oh, okay, sorry. try it. Okay. Good. TJF. Yeah. Okay. We go to the next question. Okay. Now on to our second question. What do you think of when you heard the word aging? This could be anything. Oh, yeah. Yeah. As long. Okay. Yes. That's true. Okay. What's come on your mind? Please, soon. Please respond. Okay, good. Scary. Yeah. Scary. Age. Okay, me too. Okay, good. I think it's interesting. It seems like many of you think have a lot of thought about this topic. Okay. I think we will go to the last question, the final one. What do you think of when AI is about us? Okay. I'm curious to see what's on your mind because AI is such a buzzword these days. Okay, scary, dynamic, trust, robot. Okay, human replacement. Oh yeah, that like a hot topic now. Useful, uncertain. Yeah, complicated. All you can do. Okay, good. It's like the diverse thought, no? I think oh, it's kill every human. Okay. I think it's all we got. And thank you for your response. All right. I think we will go to the next activity. We honor to have the expert with us who specialize in the very topic we just discussed. So I would like to hand the stage over to Nitichen who will guide us to the next part of our session. Thank you.
Okay. Thank you ค่ะคุณประภาดา hope you guys feel fresher. And now I would like to introduce our speaker, Dr. Tossapol Pomsuwan, research fellow at Thailand Development Research Institute or TDRI. Dr. Tossapol will share his experience on how machine learning is being leveraged to analyze longitudinal data, select features, and develop predictive models. And Dr. Tossapol, the floor is yours.
Thank you very much. Thank you, HITAP, for inviting me today. So I'm very excited, but a bit of pleasure to be presenting my work in front of this so many experts in this room and online. So the expert in healthcare, health science, and economics, most importantly. All right, I will do my best. So before have gone away from this area of research for a while, I did commit myself a lot into this project to advance the human aging research by means of aging. Can you get my slide, please? Okay. Okay. Thank you. But 5 or 6 years, I think, but that's nothing compared to what my supervisor has been doing. I think he's 30 this year. So he spent like half of his life explore on the data mining or machine learning just to improve the quality of research in human aging area. Right? But then this is the very first time for me to be presenting this in Thailand. So let me, I'm a bit nervous, so let me start with some small talk here. As Thailand is a Buddhist country, there is an very old chanting that incarnation that I go back, I return to over and over again to reflect on my daily life. The chanting goes like this. I'm of the nature to age. I'm not gone beyond aging. Am of the nature to sicken. Am not gone beyond sickness. and I'm of the nature to die. I'm not gone beyond death. So apparently, as a matter of fact, the incarnation, the Dhamma, has hold true for over 2 centuries or 2,500 years. So even with the development of technology, even with the many breakthroughs in science, so apparently there's no way around it. Maybe we could make ourselves look a bit younger and slow down the aging process, but there's no way around aging. Maybe we could subdue the terrifying diseases, but there's still no way around sickness. And most importantly, there's no way around death. So even nevertheless, I think working on increasing the quality of life of elderly people, that's something worth going for. The key term here is quality as opposed to quantity. Other people might think that living longer is something good in itself, but then I wouldn't necessarily say that. Many people in the last stage of their life and being kept alive by technology, they are suffering a lot, and simply to add a few more days to your life. So what's for really, for what purpose? But we are seeing the average median age has increased a lot for the recent years. I think people can live up to like 80 or 90 or even 100 years old. That's we have seen many cases, but so at this point, I think it's only possible that we may be able to extend our life expectancy probably to, I would say, 120 as maximum. But does it lead to any consequence? There might be a bit of concern that we are entering a period now where bigger and bigger proportion of our population are elderly. So that being said, finding a way to extend people's life, as long as the emphasis is on the quality, I think is something worth going for, and it's really an important job to do. So let's look at some positive view of the aging first. I saw the mentee, the word cloud, and most of them are quite a bit negative for the aging. So here's the outline of my talk, but right, for aging, have you ever heard of that we are a completely new person every 7 years? So this is thanks to our cell in the body that renew themselves. So, and that's even more true for the skin cell. I think if you point at it anywhere in your skin cell, it's even less than a month old. So that makes the very simple question that you may have heard a lot, but you don't want to answer. How old are you? That becomes a tricky question. So I don't know the right answer, but the correct answer should be under 7, right? Since things in your body already renew itself or replace in the new one. So in a way, you are a new person and you are given a fresh start time and time again. So that's one way to look at aging. Okay, next slide, please. Right. So there may be many aspects to look at aging. So in the biological side or the psychological side or on the economic. But let me just scope down the aging in the medical context here for the sake of this talk. So basically, it's some kind of the function in your body gets slowly not function as it used to. There is a high risk, and I would like to emphasize the second one here, diseases, age-related diseases or terrifying diseases. So it's become easier as people are more vulnerable to these terrifying diseases. So that would be a call for the fix, the intervention or the technology to help us to overcome this, to mitigate the high risk diseases, or to maybe to subdue, to have the early detection on the diseases. Okay, next slide, please. So here is the graph that I would like to show. There is both type of diseases, the age-related and the age-unrelated. So as you can see from this graph here, something like arthritis, diabetes, or the most terrible one, cancer, is age-related diseases because it's significantly occur a lot at the people at higher age. On the other hand, the unrelated one is like asthma, as it stay through with the same rate regardless of the age. Okay, next slide, please. Okay, let me highlight the key finding from the UN report on global aging trend. So the emphasis is that the rapid increase in the elderly population and the implication of by 2050, people aged 65 and older will double. So that's reaching 1.6 billion around the world. And for old age, 80 and above will even triple. So if that's not clear to you, next slide, please. So right now we have like 1 in 10 people at the old age, but by 2050, it will become 1 in 6. So this means that more people will be getting older, which will affect the healthcare, the social services, and most importantly, the economy. It's important to find ways to support and care for this growing number of older adults, which is why research on aging and health is so important. And I think we all know what it's like to do research. We need to back ourselves up with data. So after all, is this even evidence-based research or evidence-based policy? And also we need some tool, but let's start first with the data. Next slide, please. So now I'm scoping down to what my main contribution in my thesis. There are 2 parts. Let me start with the dataset creation. So I will confess here, I didn't do the data collection myself because that would take some time to get a lot of, like 10,000 of records to help me run my machine learning models. So there are some sources, some very good sources of doing aging research here. So let's start with the first one. So the first one is the English longitudinal study of aging, or otherwise known as ELSA. So this, thanks to this data set, my PhD thesis is a lot easier, and it added a lot of value to my research here, to my project. So as a brief description, this is a longitudinal survey of English population age 50 and above. So the survey around the focus is on the health data, social data, the well-being, and the economic circumstances. So the aim is to improve understanding of the aging process, and as the final impact is to inform the policies. The data collection method is, as the name suggests, is a survey, so it's more the interview and self-completion questionnaire. The individuals will be asked to perform some health, some medical tests, like side-by-side stand, for example, to make the to get the information about health condition, the medical history, cognitive function, social participation, and economic status. So because we believe that these factors are all related to aging one way or the other. Okay, and let's move on to the next slide. this is the biggest data sets in my research. So I'm really thankful that I could get a hand on this. It's the survey of health, aging, and retirement in Europe. So as it covers so many countries, like 27 European countries, so we could get the data, a longitudinal data for more than 100,000. This it is also focused on health and the economic status, like the ELSA. But the important is that in this survey, they have some kind of collection using technology called computer assisted personal interview, or CAPI. So that's make it when the staff entering the survey data, it's harder to get the error, like because of the program or the software will control what input can is valid for this field, for example. So and the last the database here is a bit different. It's called hemodialysis dataset. So this is not exactly a longitudinal dataset, because back then we worked closely with the clinician and we got the data from patients undergoing hemodialysis for kidney failure. The treatment is basically to remove waste and product from their body. And yeah, the data collection is mainly the medical and demographic information, those kind of things. And we also include that as the last data set in my project. So yeah, we all set to go. We got two longitudinal data set and another one from the clinical data, and to be able to use this for machine learning algorithm to create useful models, we need to do something about it first, and that's the part that took the longest in my PhD life. So that's the data cleansing and the pre-processing step. So since this is the longitudinal data, I mean for the ELSA and the share dataset, I need to combine the data from multiple waves. So waves here is a bit of a specific term representing the time point in the time series survey. So one wave is one time point, and it's a survey data. So there's been like, so this occur every 2 years. So the wave one and the next wave will be 2 years apart from the last wave. And in the ELSA, the fact that is useful because this survey has been allowed for like 20 years. So we have allowed 10 waves on this information, and we could construct many kind of aging research that we want. And then I will move on to the feature selection. So this also spent a long time, since we have to look at the feature or the variables in the database one by one to see that if this will fit to the if this will make a good predictor, and the machine learning will not be confused with the way the data get, because not every type of data is structured data where we could easily process, like the numerical data and the categorical data. And sometimes there will be a lot of missing value, which leads us to the next slide. So the part two is also took me, it's almost drove me crazy. So because we have to look at what we could do with this data, what's the objective of the research, and we need to set the class variable or the target variable for the machine learning. So it could optimize the to minimize and to get the cost function to the minimum, those kind of things. So it's quite complicated to get from the survey data, since they were not decided to support the machine learning algorithm at first. So cleaning is important. And another issue was the missing data. So we spent like lots and lots of time for the imputation process. The imputation process here have different kind of techniques. The most basic one, I believe, is the filling the missing values with the mean or the median. So I think that just makes sense because it won't change the distribution of the data. But then there's many drawback here because we simply just look at one dimension at a time and then just simply filling in the missing value with the mean. But then there's another technique since this is about machine learning. So we could use the model, the prediction model to fill in this data instead. But then that would depend so many variables like how is the performance of those models. If we fill in the missing value with a poorly performed models, then I think the data would getting worse and worse, and that wouldn't be worth going for. And if the missing value is a lot in some variables, even if it's useful, then if there's like 1% or 2% of the data present there, then the only choice is to exclude it from the data set. So, and there's the thing about the data normalization. Okay, next slide, please. So here's the conclusion of my first contribution here. I got in total 11 data set from these 3 database, and I used them to as a predictor model. So I use this data set to test the predictive accuracy of my models, and there's the whole thing about the sensor data, as I mentioned before, because in survival analysis, not every people follow through the study or the survey through the end. They might drop out the study for some reason. So that make it really challenging for the machine learning model because the classical machine learning algorithms are not designed to support this kind of scenario, which is unique for many other tasks. So next slide, please. Okay, so machine learning. So as I already got the popular words from the mentee. So yeah, machine learning is a sub area of AI. Okay, next. For machine learning, it's basically so what makes AI really intelligent is just that we don't have to explicitly program for the computer to analyze our data as we change the data set or having trouble with the structure of the data. We could just make the algorithm learn for the data and adapt its behavior according to the data. That is why people who is doing machine learning can adapt their project to many different domains. Such the example would be in medicine, we could use it to do the medical image, like the X-ray image, and detect what's going on and what's wrong with your body. In finance, we could use it to detect the fraud or those kind of spam, something like that. So it comes in very handy, and that's why it's quite a popular area for the decade. So, and okay, I will just skip this, but this is just some terminology about machine learning where if you need programming language, Python and R is the most popular one because the community is quite strong. They understand that you need to use the code, the machine learning algorithm for many different purposes. And you don't have to do everything from the scratch. It comes in the libraries like the scikit-learn is quite popular one. Next slide, please. So, okay, many different kind of machine learning techniques like supervised learning. I think many people have heard about it. It is when you have labels and you want the machine to be able to predict the label. The example would be to predict the disease diagnosis from the patient data. The unsupervised learning is different since the real world data often we don't have the label. Because since, for example, if there's a new emerging diseases back then 4 years ago, like the COVID-19, you could at least use the data that you haven't been able to observe before and use the machine learning to tell us something like to cluster patients in with a similar symptom into like 3 or 4 clusters to see the impact, something like that. Okay, next slide, please. So that's my thesis title in my PhD, the new random forest variance for the survival analysis. So we could do many things with the data set that we got. So the easiest one would be to try to, if an individual come in and have a yearly checkup, we could use those data and try to say that if this person has a disease or not. But then if you are talking about the terrifying diseases here, then that would be a whole different story. That would be too late. Why would we need the machine learning? So we need to be a bit ahead. So if we could have the data, since I mentioned that we are using the longitudinal data for over 10 years or 20 years. So we could use the data of one wave to predict the health condition of the patient on the next wave. So basically to predict the disease 2 years ahead, and that would be some application. Or in my research, it's called survival analysis because I'm trying to predict how long will it take for the individuals to have this age-related disease. So, and that's come in a more challenging and startling thing, like the fact that most of the records in the dataset is censored. Okay. And next one, please. Okay, sorry for the wall text. I won't go into detail, but if anyone has any question, then I'm glad to come back here. But basically, I'm trying to show that I have developed many algorithms. And next slide, please. And some of them outperform the classical method, like the Cox proportional hazard regression, by a lot. So that's the main thing about why I spend so much time develop this algorithm to make it more generalized better with these diseases. Next one, please. Okay. So for the application and the insights, I think I will just not go into the detail, and I'm looking forward to hearing from my discussants who will help me to see what's the potential of using AI in medicine or medical data. Next one, please. But there is also a challenge that I would like to talk about to discuss with the other discussants or the experts in this field about the whole thing about the data privacy, where I would need to, because the healthcare data is quite a very, very sensitive data. We could just, distribute it throughout on the internet. There would be some kind of privacy leaking. But then again, it's not like this is the dead end. Like we need to share our private data to be able to advance this kind of research. We could there have been the development in algorithm. So there's one book that I really like, which is called the ethical algorithm, and the translation in Thai is AI ที่มีหัวใจ translated by Dr. Kittiratchakool from เกษตรศาสตร์ University. So I would recommend this one, that how we can share our private data, but still being anonymous. And the next concern is it's quite, there's some worrying trend about the AI today, because one of the most popular techniques in machine learning right now is like the deep learning. I think you have heard from that. Deep learning is some kind of neural network where, for example, if you it's still a myth how our brains work, and the neural network is just a copy of our brain into the artificial neuron and make it run. So it performed very well. So you have seen many impossible tasks in the past, but can be achieved by neural network or the very recent one like the chatbot and the transformer, those kind of stuff. But the nature of them or the drawback is that they are completely black box. So for the risky operation or in the domain that you are not allowed to make many mistakes like the healthcare, for example. So that's the whole thing, that this kind of technology or innovation should be provide some transparent or explainability to make us understand the insight. So we could talk about this too. So let's go to the last slide, please. Okay, before I move this to the discussions, there's 3 areas that I would want to discuss about the emerging AI. What's the application or what's the demand? Yeah, that's the word. That's the word. The demand from the people in the field. What do we want to know? What kind of data do we need, for example? And in order to achieve that, how do we collaborate? How do we, for what party that we need to come together and try to develop this to overcome the health care issue and the aging society issue. And I think we could only achieve that with the policy research. I think that's the game changing. Okay, next slide. I think it's time for the discussion first, so sorry about that. So finally, I would like to thank the University of Kent that let me do this research and use the computer server. The postdoctoral who have funded me for like 10 years, and TDRI, and last but not least, my kind and encouraging Professor Alex Fritas. Thank you very much.
Thank you, Dr. Tossapol, for interesting presentation and also take-home message, which will be our discuss points. Now, I would like to move on to our first discussions. Associate Professor Vithala Phungphapong, lecturer at Chulalongkorn University. She has extensive expertise in statistics and machine learning. We are excited to hear her insights. So, Dr. Vithala, please go ahead. Can
you hear me well?
Yes.
Okay, so thank you, Kun Nitichen, for introducing me, and it's my pleasure to join the webinar as a discussion today. First of all, I would like to thank the speaker, Dr. Tossapol, for a wonderful talk, and I would like to emphasize that data quality is very important when conducting any analysis. Poor data quality can lead to inaccurate and biased model. Even if you use the most advanced AI algorithm, the result from the model are unreliable. But with good data quality and, of course, good data infrastructure, you can significantly reduce the time spent on data cleansing and preprocessing. I completely agree with the speaker that data preprocessing typically consume the majority of the time in data analysis process. So today I would like to share my experience when I deal with the electronic health records of the Thai population. So at that time, I got the grant from the SWRS, which is a health system research institute, to do some kind of like prediction for the diabetes onset and hypertension onset and their complication as well. And so I use the database, which is known as the 43 folder system developed and maintained by the Ministry of Public Health. And this system integrates a wide range of health-related information for patients using the public healthcare system. And we found that the data infrastructure is quite robust, which is good. However, there is a room for improvement in terms of data quality. We encounter a significant amount of missing data, and in some cases, variables such as some certain laboratory measurements, they weren't missing, but their value was very unusual and fell outside of the possible range. So at first, as a statistician, I tried to use the algorithm to detect outliers. But after we tried that, we think that is insufficient because we found that many records contain the same incorrect value. So once you apply those algorithms to detect outlier, so that's looks like the common value because there are so many records with the same numbers. So to solve this issue, we had to incorporate expert knowledge from medical professional to suggest typical range. And of course, the typical range might be depends on the study cohort, for example. So some of the lab measurement might be different from healthy cohort and versus the people affected by diabetes, things like that. And I know that at the moment, right, the data entry is performed manually, but I think that in the future, it would be more beneficial to avoid or at least reduce manual entry and using some technology, for example, the IoT or OCR to facilitate and improve data entry processes. So once we know the possible range, right, we use the techniques like visualization to manage this anomaly. And another challenge that we found arises from when we work with the longitudinal data. Yeah, for instance, a patient might be required to come in for a checkup every year, but some of the patients, they might miss some years. So this creates missing data, regardless of how perfect the data entry system is. So if a patient stop coming, like drop out in the study, right? So this is what we know as the right sensor data. And we have techniques to analyze this kind of data. For example, Dr. Tossapol mentioned about the survival analysis, right? Random survival forest can handle this kind of case. But there's a patient who maybe came in the year 2022 and then skipped 1 year, and then he came back in 2024. So that's create the missing data in the year in the middle, right? In the year of 2023. Okay. And so what we previously done is that we look at each individual for each feature and taking the average between the value of the 2 years and then do the imputation for the year 2023, for example. And this is quite simple to do it, right? But then another challenge is that sometimes some patients skip, let's say 3 years in a row, and then he show up again. For example, he came the first and the 5th year, right? And then there are 3 missing value in the middle. So what we did, we also look at the individualized level and then take fitting the trend line based on these 2 value in both ends. So that's what we did. I know that there are various techniques to improve missing data. We can go for simple methods like mean median imputation. And right now, I think that there are many research talking about using the neural network to do the job, which is called deep learning imputation. So I would like to go back to the speaker. I would like to ask the speaker to share his thought on whether it is worthwhile to use advanced technique like deep learning for imputation, or in your opinion or in your experience, simple techniques is sufficient, or should we just ignore, not exclude, but ignore the missing data, so we don't have to impute, but then we can use the modeling algorithm that can handle missing data well, for example, the tree-based model. Yeah, so what is your opinion or experience about this? Thank you.
Yeah.
Okay. Thank you, Associate Professor Vithala. Yes. So we share the same pain, right? Missing data, the data quality. So I did use both techniques, the mean, median, imputation, and or to the advanced one, which is more of the wrapper approach, where we use the machine learning techniques and try to improve them. Well, yes, the neural network seem to be the one that give the very high accuracy in the classification tasks, which makes it more, so it's intriguing. We want to use that, but then there's the whole story about the fine tuning the parameters, because like the number of layers, the number of neurons in each layers, those kind of things. And the wrapper approach would it takes a long time, a very long time, given that we use the average computer hardware, those kind of things. So I I would say that there are other methods like the KNN or the K nearest neighbor that I think it spend a reasonable time, since it is called the lazy learner, where you don't exactly create the models and it only consume the time for the classification when it really has to impute some of those missing values. So if the number of missing value is not a lot, then I would recommend going with this technique. But yeah, for the neural network, I'm never a fan of it. The nature that it's a black box model, and it also it consumes a lot of computational power. So that's my answer.
Thank you very much. I totally agree, because when you deal with a big data set, you don't want to do like add another layer of analysis just for the imputation. Take a lot of time doing that. Yeah. Thank you very much for your insight.
Thank you.
Okay. Thank you both Dr. Tossapol and Dr. Vitara. It's very interesting discussion. Actually, I want you guys to discuss about the thing that quite technical. However, because I'm also like a health data scientist, so I'm interested in machine learning. And now I want to go to the next discussions. Dr. Pitapon Kingkao, researcher and head of research unit at HITAP. She brings a wealth of experience in digital health from a health economics lens. Dr. Pitapon, over to you.
Thank you very much, Ms. Nitichen, and thank you very much, Dr. Tossapol, for your presentation. We did have a talk beforehand, and I really find your talk interesting. And machine learning and AI will be the future of our healthcare, because it will help our healthcare system more efficient. However, I think for me, I would say that the machine learning is like the fortune teller. So for those international audience might not comfortable with the concept of fortune teller, but in Thailand, many people go to fortune teller asking about whether or not they should find a new job or they should dump this guy. Anyway, so I would say that having a machine learning is more like predicting into the future, whether you will age at a certain point, whether you will have a disease at a certain point. There are many applications of using AI and machine learning at the present, and we have been using it for quite some times. However, the application of these algorithms, it kept in the black box. Like for us, like population, like patient, we do not know how reliable these tools or this machine is. So is there any movement in terms of like on your perspective, like being a researcher, is there any movement about having this algorithm being more transparent, being critiqued or being looked at, so that the user is more comfortable using this kind of machine?
Thank you, Dr. Pitapon. Yes, there's some attempts to try to explain this black box model using another black box model. So basically to use AI to understand themselves. And yeah, then I would agree that there's some knowledge discovery, like the most recent architecture of neural network, the transformer. So they could try to expose it a bit, like what's the very first layer would represent and the last layer would represent those kind of things. But then it's not just two layers, right? There's the whole many things in within the hamburger right here, and it's still very hard to understand. So for like the random forest, I picked this model for the nature that it's a tree-based model, and it's kind of a white box, but no random forest. I couldn't say completely that it's a white box. But the best I can do is a gray box where we can interpret to some extent what's the feature or the factor that have the most effect on the class variable, on the target variables, those kind of things. But for the neural network, it's not really my area. But yeah, there are some attempts to make this modern AI, this very advanced AI, more accountable, or more interpretable to some extent. But then one or two layers, I think they claim that they could do it, but that's nothing compared to the real models that have been used a lot.
Thank you very much. And maybe one more point on the data. I think you mentioned about the ELSA data set, which is really useful for like many researchers to utilize the data set in this area. In Thailand, we do have longitudinal cohort. However, it's not maybe it's only been like 3 waves, but they do collect the data of EGAT population. So we use this to predict the chance of having stroke or heart disease in the future, or even kidney disease. So but this come with the cost, right, of getting the data set and having it transparent to other research network. Do you think how people who collect the ELSA data set, how they structure or plan to have this data set available to other public? So do they need to have any agreements, or do you need to do any ethical clearance before getting the data set for your PhD when you're using it?
Yes, and we have to renew this agreement or contract every year to also to be able to use this data and to get the new wave that they have published. So there's some term and condition or term of use for those kind of data set.
So would you say that this ELSA dataset is an open source dataset, or is it closed for those who ask for it?
I think it's available for doing the research, and for education.
I see.
So that should be for free. I'm not really familiar with the licensing that much, but if you ask for them, sure, I think they could provide them.
And also, when you compare between the data set that is structured and planned for research and other data set like 43 folder, like the real world data set, what kind of different challenges that you need to come across when you utilizing this kind of data set?
I haven't seen the
the 43. Okay, so maybe it's health records, electronic health records of hospitals. So maybe a lot of missing value, or maybe unstructured data, like a text-based data, for example.
Okay, so that's like two questions. So for the missing value, I think we all have that problem, and also as Professor Vitala also mentioned that it's very painful to clean the data and impute the missing value. But yeah, there are techniques for those, like we just discussed about the wrapper approach, like the KNN and the neural network. So really depends on your resources. And as for the unstructured data, that's why an interesting question, because it used to be very hard to deal with unstructured data. But nowadays, since we have the AI, the generative AI, or the transformer model of the neural network, we could convert those texts which is unstructured into the structured data in a numerical way that the computer can make use of, and it is very accurate. So the whole thing in the end, NLP really advanced a lot, and it's become tangible for us now.
Thank you very much, Dr. Tossapol. That's fascinating, and looking forward to the future application of AI and machine learning.
Okay, and yeah, you just mentioned that many people have used the application of AI for fortune telling.
Yes.
Interestingly, the ChatGPT have been asked a lot from people in Thailand about 2 to 3 digits numbers. So what that will be used for is like, I think we all know.
Okay, thank you very much.
Okay, that's really good discussions. And we now let's welcome our third discussant, Mr. Mark Landy, Program Officer at WHO Country Office for Thailand. He is an expert in digital health and health information system. Mark, please share your thoughts.
Great. Thanks so much for the opportunity to be invited as a panelist for this discussion today. Can you hear me okay? Just check again.
Yes.
Okay, excellent, great. Again, I appreciate HITAP for organizing this webinar. Dr. Tossapol, thank you very much from the great learning and experience of machine learning applied in healthy aging. I think I wanted to address some aspects of this work, and recognizing that AI and machine learning should not be implemented in isolation, because of course in the landscape in Thailand there's a number of digitally enabled tools and technologies being utilized, and so firstly I think it's strategically important as mainstreaming of AI enabled machine learning or deep learning tools are embedded into the predictive analytics that are applied and used for patient care, et cetera, that these are integrated into the existing digital health strategy and the infrastructure, and infused into the ecosystem that exists here already in Thailand. So it's really going to be important as research matures into application and use, and realizing all of the power and benefits by at large across the population, that that the data architecture itself can support this integration of this vast and diverse data sources. And as you alluded to already, drawing from data sets, but also, of course, in Thailand there is an enormous amount of medical records, electronic health records, and data from wearable devices, other national databases, et cetera. So this will be very powerful as you start to apply this particularly with data here in Thailand. I wanted to emphasize a little bit on the importance of data collection quality, as well as this issue around the architecture, because of course, in aging research, these machine learning, deep learning models, they've shown great promise, as you have demonstrated already, looking at predicting the progression of chronic diseases, looking at imaging and genetic data, et cetera. But it'll become increasingly more important and essential that this is, underpinning this is a foundation of well-structured a well-structured data architecture that will allow more seamless data integration, data exchange, and processing across various health systems. I would be remiss if I did not also raise the importance of the ethical considerations and data privacy that, of course, are essential. And WHO has produced already guidance on ethics and governance of artificial intelligence for health. And I think that's a valuable resource that it emphasizes the importance of transparency, fairness, and accountability in AI deployments. And other parts of the United Nations, including the ITU, have an AI for Good initiative. All of this is important, and I think Thailand will need to ensure that laws and policies and regulations ensure AI and ML applications used in healthcare, irrespective of risk or benefit associated with the technology, that they, in essence, meet ethical obligations and human rights standards that affect, for example, a person's dignity, autonomy, or privacy. This will be, I think, very, very significant development as this research, again, becomes more mainstreamed and integral into health service delivery. I think also I wanted to mention the importance of effectively looking at these ML applications and aging research and thinking forward about interoperability of the data with other data systems. For example, reinforcing the learning algorithms successfully to optimize resource allocation in healthcare, as well as thinking about how to use this technology to improve efficiencies in public health strategies going forward. And finally, I also feel that these models are going to increasingly become an integral part of the public health strategies here in Thailand. And I know that there's a number of actors across the health different agencies, but also the entire ecosystem of different actors, and it's important that we have everybody on board, that we don't continue to work in use of AI or these kinds of technologies in isolation, that there is a lot of sharing and complementarity amongst different agencies to share the developments as they emerge. So with that, I just want to, again, just stress the importance of aligning this work with the National Digital Health Strategy, prioritizing data quality and privacy, ensuring that the infrastructure can support the emergence of and use of these technologies, and adhering to the standards that are needed to ensure that these cutting-edge ML models will really improve the health outcome for aging populations here in Thailand. And I would say finally that this is becoming a real learning lab here in Thailand in the use of AI. And I hope that the experience that you're gaining, Dr. Tossapol, as well as other researchers, will help other countries in low and middle income settings to advance as quickly as we have here in Thailand. Thanks.
Thank you, Mark.
Dr. Tossapol, would you like to add any comments?
Yes, I think 2 years ago I went to a conference, and there was a talk about how comfortable for the patients to know that their the check-up data will be analyzed with robot or AI, those kind of thing. And I think that the figure was around 20 to 30% that they answer that they are comfortable with this. So I would say this is still not really a low number, so it shows some potential. But then, yeah, with the development, with the research, and how to make this AI and this model more transparent, and the expert would come together and say that, yeah, they are safe. will increase this percentage. And yeah, that would be a way to go in the future. But then right now, I think even among the expert, the developer, or the regulator, we are still arguing about many things about this ethic and regulations. And yeah, I would say WHO standard or the guidance will play an important role for developing the AI in Thailand here. Thank you.
Okay. Thank you, Mark and Dr. Tossapol once again. Because we have like time constraint, so I do like to open the floor for questions from our audience. So you can either raise your hand, your virtual hand, or type your questions in the chat box. We'll do our best to address all your questions. And I found some questions already on the screen. Let me start with the first question. How much data do we need to say that this model is reliable for the whole country? Dr. Spon, and every discussion, you can share your thoughts.
Yeah, let's make this a panel discussion. So I don't, okay.
Please go ahead. I can follow you.
So I don't know what would be the magic number. So this data, the more the merrier. But no, I wouldn't say that's true. It really depends on the quality of the data, how well it represents the population, and how well it's generalized. So if the data is very high quality, spread throughout, and with very low bias, then I would say maybe just a few thousand. Professor Vitala.
Thank you. So this is a bit tricky question because sometimes it's hard to say that, okay, this model is reliable for the whole country. But what I did for the project is that actually the 43 folder system, there are more than 30 million people in that database. But what we did, we can do like the pilot model first. So instead of investing your time, analyze all let's say 30 million patients, you can just like do a sample. Okay, so first of all, I think we use a sample less than 1 million, maybe like 500,000 patients, and try to do everything like data cleansing, imputation. We try several models to see, okay, once we satisfy with the model, we try to validate the model to the bigger population. So at the second stage, we run another round of, we kind of like, we do our analysis, but now we expand the number of patients to, I think, 1.2 million patients. And some of, to predict the diabetes onset, for example, I think that we got the very similar AUC, which is the evaluation metric to evaluate the predictive performance. So then we just stop there, that okay, 1.2 million might be good enough. But then I think that for the next phase, we probably try to validate more with more patients. So maybe like 5 million people for the next round. And then actually we could also try to deploy the model. So once we think that, okay, my AUC is more than like 0.8, which is 0.85, if I'm not wrong. Yeah. So if we satisfy, we can actually deploy the model and see whether the real performance for the new data coming in. Yeah. So it's a bit tricky question, but then you don't have to invest all of your time analyze the big data at one point. You just start with the pilot project first. Thank you.
Okay. I can't agree more. It's like sometimes we can use as much as we have. For example, like some rare disease, right? But sometimes we have vast data sets. Okay. Another question we have is, how do we know that the data will be saturated? I'm not sure whether we can detect that. It's quite similar.
So one of the concerns when we develop or training our machine learning model is the word is called overfitting. Overfitting means that the models, when it's not complex enough, it will be too focused on the training data and try to fit itself into this training data instead of generalize to see the pattern of the data as a whole. So that's why there is the process called validation, like cross validation to verify first. So you will split the data into the test set and the validation set, and we use the validation set here to see that if the model that you have developed not overfit to the data so much. So I'm not sure if that answered the question.
Any discussants want to add more comments? Okay, so let's move to the next question. As data is sensitive, is there any particular process to get this kind of data, or what would you suggest we do if we want to conduct a study like this in the future?
Maybe I could help. I think one of the importance about longitudinal data is that you be able to follow that particular person throughout the years, right? And you can get their baseline and you can know what's going on in the future and you can use those data to predict. But for a certain reason, this kind of data is expensive and you need like the design to like you need to design how to collect the data, how you're gonna follow up, how you maintain those particular population, because you know those people are not rat where you can contain them, you know, they move around, they go abroad, you know. So it's quite difficult and time consuming, resource consuming data collection. So we are now more, you know, goes toward the real world data set. However, it's also come up with like challenges as previous speakers mentioned, so about the data quality. So maybe in the future we can utilize data that we collect from Internet of Things, like wearable devices, or we can focus more on patient groups where they need to measure their blood pressure every day, or diabetic patient where they need to test their sugar level every day and use those records to trying to come up with a prediction model, and then we can test this in a more general population. So maybe this is more like feasible way to move forward, because you know in Thailand, even though we have a national health examination survey, but these are multiple cross-sectional studies, so we cannot link each individual like all the time. Even the health exam survey in Thailand, we had a discussion with National Statistic Office. They say that these are not the same group of people, so we don't really have longitudinal data collection unless if you count the EGAT one. Yeah, but those are a certain group of population, you know, like workers in more higher in a higher tier of socio-economic status, which is not a representative for maybe the whole population. Yeah.
Thank you, Dr. Pitaporn. Now it's like we have more and more questions. The next is to predict the related disease which medical records would be required, such as blood pressure, blood sugar, etc. Given that different diseases maybe need different medical data to predict, and how often this information should be updated. For example, if the individual does not do regular health checkups, would this prediction still be accurate? Yes, I also think it's already answered, right? Okay, and please let me move to the next question. Would it be possible to make some kind of prediction publicly available, for example, using a Shiny and allow people to enter their input and see the prediction themselves?
Yes, I think that's the whole point about the machine learning models, where it can be used to publish online and make an application that, so once the models has been completely trained from the training data set, and then it will just stop its evolution right there, and then we can be used to see the new record or the new individual, and it will be able to predict when the about the diseases of the patient, those kind of things. Yeah.
Okay, and then what are some of the considerations for using AI and ML in low and middle income countries as resources are limited?
Can I jump in on this one?
Yes, sure.
Great, thanks. Yeah, I think this is a very important question, and I think we've seen some examples of countries that get very interested in the next shiny new thing like AI, or previously it was big data, or some of these emergent technologies and digitally enabled tools. And so I think first things first is to ensure that there's a policy question, there's a priority, what we say a use case, there's a clear need that's identified, and not just point these tools at data sets and see what you get, but really have a real clear prioritized question or critical issue that needs to be addressed. So in other words, don't focus on the technology, but focus on the policy or the decision that needs to be evidence-based and better supported. And that's very fundamental, but you would be surprised how often we see wasted investments, very scarce resources in LMICs, because there's too much interest and not enough identification from a user and beneficiary perspective what is of highest priority. It should start with that user focus, user needs first, and then look at what technologies like AI can help solve those problems.
Thank you, Mark, for your answer. And we also have the next question. Why we are discussing electronic health records? How about patient-generated data, especially since elderly may not be acquired with using technology such as wearable, like maybe the thing that Dr. Pitapon mentioned about Internet of Things? Because we talk about elderly, right?
Yeah. Okay, I can help respond to that. Obviously, digital tools or this kind of technology, it won't be a familiarized tools for elderly, of course. And in Thailand, especially, we have launched a program, a policy called One ID. So basically, a patient can go around in certain because we did a pilot provinces first. So basically, patient can go to any hospitals, and then they need to install what we call Moprom application. So what we found is that for those who are elderly, quite difficult for them to install the app, to understand what are these applications. So to not leaving these people behind, our healthcare system need to have plans that may not just fit one group of population, but also fit both or maybe multiple group of populations. So digital tool is good, but maybe it's not necessarily best for people who are incapable of using it. So for me, my suggestion would like to have another types of interventions to accommodate this group of people, or have at least assisted group of people, maybe young generation, who want to become volunteer, help out. So actually in India, I think there are a group of a network who help with the locals to set up to install application, to train the elderly how they can use these features. So yeah, that would be my response.
Thank you, Dr. Pitaporn. And the next question, it is a long question, so maybe both speaker and discussants, you can read together with me as well. Could you explain more about feature selection? What we have done is selecting the features that the literatures have reported. Furthermore, when we have multiple diseases that we want to build the predictive models, such as working on both diabetes and hypertension, we also try to use the feature that reported in diabetes but not in hypertension literature and apply both into both diseases. However, for the big data set, there are a lot of potential features that we can try. For example, new diseases not reported in the literature, or the variation of the features such as blood pressure variation between each time period. What is your approach to select the features when there are a lot of potential features that we can test on?
So to sum up, maybe model selection, it will be your more expertise. Yeah.
Yeah, there is some kind of pre-processing step like feature selection techniques. I published one of the paper on correlation-based feature selection, where it was select the variables that highly correlated to the class, but has a low correlation among themselves, and that's believed to be the effective one to compute the pre-processing step before using the machine learning. And then again, there is the wrapper approach, like using the like Dr. Pitaporn said, use the something like the tree-based model, because it has a built-in feature selection. So build the tree first, and then see the important feature which come at the top of the tree, those kind of things. So, and this is still in the pre-processing before to the process of training and applying the machine learning algorithm after that.
Okay.
So I would like to add something. Actually, Dr. Wasin is one of our team to help for the project. So without him, we cannot finish the project. So actually, I think that we can explore instead of using just a previous literature that is like for the confirmation, confirmatory analysis, right? We could do like explore more features. This is part of like exploratory data analysis. There are tons of literatures about when we have the massive variables, how to screening features. For example, I think that in statistics journal, there is a method called SIS, from the professor in Princeton, that talk about when we have the massive number of features, we can do the screening first. Yeah, and that's very fast. I actually have applied with the genetic data. So sometimes I have to deal with like million features and then try to find the gene that's susceptible to some particular disease, things like that. So there are methods to help for the screening first. Thank you.
I would like to add a little bit about since you give some example about diabetes being the disease that you particularly interested in. So one thing that you would need to do is remove the variables that is define the diabetes, like I believe it's the sugar level, right? So otherwise this variable would just come at the top as a highly predictive feature, but then we wouldn't gain any insight about it.
Okay, and we have last two questions. How can we avoid the privacy problem or PDPA issue? Do we need to issue during the consent?
So I think all the data or like any kinds of data are governed by each country's PDPA. Different countries may have different clause or variation. In Thailand, we do have a say about like data protection, but also if it's for emergency use, then these data can be utilized for public emergency, for example. However, the data should be protected at all costs, and it should be anonymized, or you would say that any kinds of data that is available for the public, you shouldn't be able to identify whose that data come from. So I think we all have this PDPA governed the utilization of the data within the country. However, it's up to the researcher on how to utilize it. And with the research data, we all need to go through the ethical clearance and how we need to conceal all the information that can be identified. Those people who give us the data.
Right, and also if you are the organizations from the government sectors, I think PDPA is hardly applied for if you're exchanging data within the government organization. And also, if you use it for research-based or education-based, there are 7 to 8 bases that we could use. And the last one would be the consent base. But if we use this for research, I don't even think that we need to go that deep into the consent. And also, I just mentioned one of the book called The Ethical Algorithms, where they try to develop techniques or algorithms that add noises to the data, so you wouldn't be able to identify the patients, but then you could use the data to analyze it, your machine learning or statistical models, and it still would give the same result without affecting the performance.
Okay, the last question. Have you guys have any experience to perform the post-survey after you establish the model to the public sector? How do they say? Have anyone have like any experience about post-survey? Oh, okay. No one have the experience about post-survey.
Yeah, I do think that's a good suggestion. We should get some feedback for about the project and about the AI way, the very new innovation and how we use it in different kind of domains. And yeah, what do they say about this? Thank you.
Okay, thank you. And it's like we approached the end of the session, and I would like to first thank to Dr. Tossapol Pomsuwan, Associate Professor Vitthala Phungphapong, Dr. Pitapornกิ่งแก้ว, and Mr. Mark Randy for their time and valuable contributions today. And I do also like to extend my thanks to all of you in the audience for your participation and questions. We hope you found it informative and inspiring. So it's like next time we can organize this webinar again, right? And next slide, please. And as we close, let's remember the words from Yang Lecong. Please forgive me if I pronounce it wrong. Our intelligence is what makes us humans, and AI is an extension of that quality. It's up to us to harness the extension responsibly and ethically to create a future where technology and humanity work together to promote health and well-being for all, especially as we age. This concludes our webinar. Have a wonderful day.
Thank you very much ค่ะขอบคุณค่ะ
Thanks.